Well, it's time for another lesson in Prograph. It's been a while. Just to refresh, we had discussed in the previous lesson how to annotate various operations with control annotations, and we discussed the next case, the continue, the terminate, the fail. We did not discuss the finish control annotation, nor did we really discuss many of the others. The super did get discussed, but not the repeat, nor the inject, list, or loop control annotations. And in this lesson, we're going to delve a bit more deeply into those control annotations. Well, let's go bring up some example code. This should look familiar from the last lesson. I was going to delete it, but you know what? I'm just going to create a new case. I'm going to hold the command key down and click over here in the dock. Made a new case. I'm going to move it up to the front here. I'm going to save it. Now, it's a little tricky to move these input bars. A trick that I use is to do a command T, which tidies things, and then I click up here to resize, and then when I pull it back out, I get a nice, beautiful repositioning of the input bar. That's just me, but that's one way to get the job done. Well, let's discuss repeats, lists, and loops, and I think one of the best ways to do it is to think of a use case, and this one, the one I've got thought of, is to add up all the numbers from 1, I don't know, till 10. I don't know what that's going to turn out to be. Actually, I think it might be 100 or 121. Not sure. So let's create a list. Now, there are a couple of ways to do it. One is to simply type in a list. So there's a list of 10 integers, and by doing a command shift D, I can execute it, and I can just show you that what we've got is a list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, that's one way to do it. I just hit the return key again to exit the case because it was ready to execute the output bar. Oh, I think I called this the input bar, but it's in fact the output bar. Another way to make a list is to use the make list primitive. And if you double click this, and you're lucky to have a system that the help works on, it will take you to the Marten help and tell you a little bit about the make list primitive. You need to give it the length of the list. You can optionally give it a start and a step. In fact, we will demonstrate all of that here in this example. So the documentation says it'll take a couple of extra inputs. We want to make it 10 long, and here's one way to do it. We've already made a list that's 10 long, so I'm going to hold down the option key and then the command key and make a new operation, and I'm going to call this parenthesis length right parenthesis, and that is a primitive which will return the length in number of elements of a list. So that's going to automatically return 10, and I want it to start at 1, and this only works for integers, but if you want, you can then say I want it to start at 1 and step by 1, and now that's going to make a list 10 long, and let's just do a command shift D and see what happens here. Well, we got the list length 10. There's a 1. There's a 1. Oop, I haven't executed it yet. Now there's a 1. And now it's made a list, and sure enough, 1 through 10. I can back up by holding down the command key and clicking on the step, and I'm going to change it to 2. Let's see what happens there. And now get back by double clicking to my executing method, and now I've got a 2 there, and we can see the effect of the step. It started at 1 and went up by 2 every single list item. Okay, but we're going to stick with our original use case. I'm going to back up, put a 1 in there. Now I've got this thing executing, but I'm just going to hold off for a second and add in a little more code. What we want to do is add all these numbers up. And I already know how to accomplish this, and I'm just going to illustrate how I plan to do it. There is an integer addition primitive, and it's the plus plus, or you can type I plus. They are exactly the same thing. And I want to add the total, the running total, or I want to add each item in this list to a running total. And as it runs, it's going to continually add all of these things to the running total, and finally I'll have the complete total. So that's going to involve repeating addition over and over and over and over. Well, I need a running total, and my running total at the start is 0. The total, I haven't added anything to it yet. It's got to have 0 as its initial value for the running total. And then I'm going to add 1 to 0. So I have my list, and I'm going to add 1 to it. Now, as it stands, this is not going to work, because if I get back to my executing method, I now have 0. Oh, let me back up here, make sure that that's now a 0, and that's a list, and it's going to say, nope, type 2, notice how it says I plus, because I plus is actually the fundamental name for that operation. Expected a value of type integer, but found type list. Oops. So we give you a message here telling you that you've put the wrong things in. Needs an integer. Well, let's get back to editing the code. There is a way to supply each element of the list to this operation. And what we're going to do is make that a list input. Now notice what happened here. All of a sudden it got stacked up like a set of cards, and that means it is now a repeating operation. You can take any operation. Let me just put divide, and you can repeat it. Generally though, you don't want things to repeat forever, so there's got to be a little more context for the operation in a repeating sense to start and stop appropriately. Whenever you supply a list as an input, notice the list input there. This is a regular terminal. This is a list terminal. Whenever you have a list input, it has to go to a repeating operation, and each time that operation repeats, the next element in the list will be supplied to the operation as data. And we'll do a more complicated example here to really illustrate that. So this is going to add things up. Let's see what happens though. Let's get back to it. Now it's going to add the list to 0. What do you think is going to turn out to be the final piece of data supplied by the root? I am betting it's going to be 10. Oh, it's 1. Well, obviously I don't know quite what's going on here. Let me back up, just make sure that that is the case. There we go. That is exactly what I expected. So what it does is it added 1 to 0 and provided that answer. And then it immediately repeated, it added 2 to 0 and provided that as the answer, overriding the 1 that was there just an instant before, and then 3, and then 4, and 5, 6, 7. Finally, it gets to the last element in the list, and it adds it to 0 and supplies it as the output. So the final output is the last one calculated, and it's 10. This is not what we want, though. We want a running total. So let's back up here. Command click on it, bring up double click to bring the code back to the front. What we want to do is feed the output back in as an input. And the way you do that is you can select either the terminal or the root, but then you hold down the option key and you just connect it back up there. Bam. Now, it's hard to see, but if you really look closely, it's no longer a complete circle. We should draw this a bit better, but we're lazy and we haven't gotten around to it. And if you'll look at the one up here, it's a little hard to see, but it is also not a complete circle. And the intent is to sort of suggest a loop. And if you've used the old Prograph CPX, you may remember a pretty well-defined bit of drawing that drew an actual up and down in a loop. The problem with the old Prograph CPX is these things had to be directly under each other, whereas in Marten you can move them around. And you can even cross-link them. There's no indication visually that this goes with that. If I had another loop here, I could connect it this way and I could connect this to a loop over there. That can be pretty convenient. However, visually it can get confusing as to what's going on. So I recommend that although you can put it anywhere, that you stick with sort of the Prograph CPX convention and put it right underneath the other partner that completes the loop. Okay, you can imagine what's going on here. The first time this operation is executed, it adds 1 to 0, and then it feeds the answer back up here to the terminal. So now this terminal, the next time around, has a value of 1, piece of data that contains 1, and that's going to be added to the next element in the list, which is a 2, and so forth. So we're good to go. Got a 0 there. Got a list there. Let's hit it. Bam. What do you think it's going to be? 1 plus 2 plus 3, that's 6, plus 4 is 10. There's a formula for it. It's either going to be I'm not sure what it's going to be. 110? It's either going to be 100, 110, or 121. Let's see what happens. 55? What's going on there? Is that really true? 1 plus 2 plus 3 plus 4. That's 10. Well, I guess it's got to be about that. I apologize for my... In fact, how could it have ended up being 100? 10 times 10 is 100. I don't know what I was thinking. Oh, well, now I understand. It's 10 times 10 plus 1, which is 11. That's how I got the 110, but I forgot to divide by 2, and that's what gives me the 55. So I believe the mathematician Euler years ago, or maybe it was Gauss, impressed his teachers by coming up with a general formula for summing up all these numbers. You visualize it as a rectangle or a square, and you slice it in half. 10 times 11 divided by 2, 55. All right. Well, let's try this a different way. Let's make a local. And we'll call, what are we going to call this? We'll call it add to running total. And I'm going to do a Command Shift L and hit the return key. Now I've got a local. And we're going to make it look just like we did before. This is going to be a list input. This is going to be something that feeds it back. So I'm going to select it, hold down the option key, connect it to the terminal, and I think we'll show it to the audience. Alright. Inside this local, we're now going to add these things together. And generally, this is what I do when I'm writing commercial code, is I don't take the primitive and put list inputs to it or loop inputs. I tend to put those things inside locals because oftentimes I want to do a little bit more. Sometimes I'll test it for valid inputs or something of that nature. But now I'm going to put a breakpoint on it, and we're going to see this thing in action. Alright, Command-Shift-D. First time in. Got a 0, got a 1. In a certain sense, this is showing you what happened the first time around, only sort of behind the scenes, deep in the guts. So it adds them together, gets a 1, passes a 1 out. Up, it's being run again. That's because of the repeat control. Now, instead of a 0, it has a 1 fed into it. Here comes the next element of the list. 1 plus 2 is 3. And you get the idea. 3 has been fed back in, added to the next element in the list, which happens to be 3. And now we're up to 6. Now we're up to 6 coming in, and 4 being added to it. Now we're up to 10, and so on. Now I get rid of the breakpoint. And sure enough, 55. Now we're in a position to discuss the finish control. Let's suppose that we stuck a null in the middle of this. The null value, which is a special piece of data that means nothing. It's no kind of object whatsoever, no piece of data. So I'm going to split this list. And the split nth primitive splits an existing list into 2 new lists. The first list consists of the first n elements. So it's kind of like the prefix operation for a string. So let's split it, the first 5, and then we are going to attach a null. So I'm going to illustrate the use of some list primitives. So I'm going to attach a null. I'm going to split this thing right down the middle, and I'm going to put a null to the right of the 5, if you will, and then I'm going to join it back up with the other portion of the list, the 6, 7, 8, 9, 10, and then that's going to be my list going in. Okay, attach right creates a new list concatenating an existing list in one or more provided elements. And I guess I can't bring that back to the 4. And join concatenates 2 or more lists. What handy primitives. I'll tell you what, you'll use those a lot. Okay, Command-Shift-D. Let's get to it. So it split our list into the first 5 and the back 5. And now I'm going to attach a null to it. And now we've got a list with a big old null in the middle. And that's one thing about lists in Prograph, is they do not have to be homogeneous. They can have all kinds of things in them. So you can have a list of dog, cat, rock, piece of string. They don't all have to be integers or strings or all of the same type. Now, that null is going to cause the plus primitive to barf. It's no good. And so what we might want to do is we might say this is a list that we're willing to add up all the numbers until we come across an irregularity. Let's look for that null. If it is null, I'm going to send it to the next case. So this circle indicates that this next case control will fire on success. In other words, if null matches what's coming in, which is another way of saying if what's coming in as a piece of data is a null, then successfully fire off the control annotation and take us to the next case. So let's put in a next case. When it's the next case, we're going to take the current running total, and then we'd like to stop, and that is the point of the finish control annotation. And notice that by default, when you attach it to the bottom here, when you attach it to an output bar, you're pretty much always, this is the typical use case for this type of control annotation, and that's why we typically have this by default a success. So it's going to finish on success. It's going to come down, it's going to successfully execute this operation, and then it's going to finish. And finish means exactly what you think it means. It means stop repeating, even though there's more to the list. Alright, let's see it in action. Well, you know what? Just to check on things, I'm going to go to the next case by using the arrow key and put a breakpoint in there. Let's just make sure things are going. Now, we want, if it got to here before executing this match, we'd be in trouble. Typically, when you add any kind of next case control annotation, any kind of the typical next case, continue, terminate, and so forth control annotations, the Marten editor will resort the operations so that this will come before that even without placing a synchro. Remember, a synchro is created by holding down the option key, clicking, then holding down the option key. It creates those half circles which indicate this operation will be executed before that one. But typically, just by putting it in, the editor will resort the operations behind the scene. You won't notice it. The way you can always see the order of execution in your case is to select an operation and then hit the tab key, and it will go to the next one in the list. And you see that the input bar, of course, is always executed first, and then it went immediately here, even though this is an operation we added later than chronologically than when we added this. So now it does the plus operation, and then it executes the output bar, and then we're done. So it's always a good practice. This is something Jack did all the time, is after you've created a case and you've got some control things going on, always select the input bar and hit that tab key and make sure things are really going in the order you want. Alright, go to the next case. Once we get there, we're going to break. Let's see what happens. Bam! We shot over there. What is this? Well, it better be a null, and it is. And we'd better sum up to 5, which would be up to 4 is 10, 5 is 15. There we have it. Now, what I'm telling you will happen is this 15 will be executed by the output bar. The operation will succeed, therefore this control annotation will tell it what to do because it's activated upon success, and what it's telling it to do is if you successfully execute, then stop. Let's check it out. Yep, 15. There it is. So this has been a quick tutorial discussing, or quick lesson rather, discussing the various control annotations that we've neglected up till now. The repeat, which causes an operation to execute successively forever. However, if you've attached a list to it, it will only execute as long as there are list elements to process. So typically you see repeat used with a list. Anytime you provide a list input to an operation, it will automatically be turned into a repeating operation. And there's another special terminal and root that can be used with a repeating operation, and those are the loop roots and terminals. And we also discussed the finish control annotation, what to do when you have this operation annotation is determined by whether you succeed or fail, but if you match the condition, then it will stop a repeating operation. All right, well, hopefully we'll get to the next lesson a little bit sooner than we did this last one.